Welcome to the latest DesignSpark Ask the Expert series. Today with me in the studio is Mikael Edholm. He's a business development executive with IBM's global electronics practice and has a specialism on the network operators. And today we're going to talk about 5G.
Yes, thank you. Thank you.
So 5G deployment is well underway now in many countries. It's promising much faster, significantly faster internet speeds. What do you see as the main factors to speed that deployment in different countries?
I think first of all it's important to see how every generation of wireless networking is being deployed. We've had 1G, 2G, 3G, 4G, and now 5G. And it's a very cyclical business. Each of these cycles here is about 10 years. And what you see is typically a deployment cycle where the first 5 years is all about coverage. It's about getting the base stations out there, putting them antennas in place, making sure that we cover the area that needs to be covered. And that takes about 5 years into each cycle. And then once you have all that, things are up and running, the users are using it for whatever their purpose is, then it's a matter of adding capacity to the existing coverage. So the last 5 years is always about capacity, adding more functionality. So in the initial phases, what you will see is cases, use cases, which makes use of the limited coverage that we have in the beginning. And that will typically be a fixed wireless solution. And that's why in the US today, you will see AT&T, Verizon, the others, they go city by city by city and say, okay, we have 5G up and running. Yeah. But it's really not a mobile 5G that is on there. What you have is fixed wireless solutions for specific purposes. And that has typically been the case also with previous generations for the same reason. So what we will have is initially fixed wireless, later on more mobile cases.
Okay. Do you see that the infrastructure of 4G will be required to produce 5G and the spectrum reused, or do you see that many applications that are traditionally today on 4G will stay on 4G?
I think a lot of applications will stay on 4G because not everything benefits from the new functionality that you have in 5G. Increased bandwidth is one of the functionalities in 5G. The other ones are massive communications capabilities in terms of densification. You can have more and more users per limited areas, and you do that by reusing the spectrum. So it's a lot more spectrum efficient. And then finally, of course, you have also the low latency part of it. But not every application that we have in use today will benefit from neither more bandwidth nor more sensors or more devices out there or better latency. So a lot of things will most likely stay on 4G, just like a lot of applications today wouldn't use more than 3G. Right. So what you have instead is a new generation of networking that over time will allow us to do new things that we haven't done before.
Now, within the telecom world, software-defined networking and network function virtualization has been used extensively and continues to be rolled out today. But do you see that the industrial customers and commercial operations can make use of virtualization?
Oh, absolutely. First of all, virtualization is something that we've used in other areas before. I mean, many years ago, we started using virtual machines in order to increase the capacity of CPUs. Because we had constraints on the capacity at the time. So we virtualized the CPUs. Then we started having problems with storage. The vast amounts of data that we generated needed to be put somewhere. So we virtualized storage. Right. We call it the cloud.
Yes.
Now we're going to the next step where we actually virtualize the network itself. And doing that means that it's not only going to be one cloud up there. What we have instead is a possibility of moving the compute functionality to where it's needed. And where it's needed is where we have the latency requirements and matches. Yeah. So you will see a hierarchy of clouds. And that means that any industrial customer, or as well as the telecom operators, will need to develop the functionality to fit the right level of the cloud. And that's why we have this big debate at the moment about edge computing, for example. Yes. And that is something that is very much a concern of manufacturers in particular, but also other industries.
One of the areas that 5G seems to rely upon is going to be the backhaul and the infrastructure that's in place. How do you see that varying by countries? Because some countries have been a little bit more perhaps forward-thinking in the way that they deployed the backbone to the telecoms network, and perhaps others haven't. Is it still seen as a vital component to the success of 5G?
Oh, most definitely. It is a vital component, because the amount of data generated by 5G will not stay in the last mile. It will move further into the networks. A manufacturer that sets up its own 5G, private 5G network, for example, may have more than one plant. And you need to move that information from one location to the other. And in some instances, we have some of the campus networking manufacturers that have developed equipment with up to terabytes at the edges. And what you do is you can then download a complete factory configuration into those edge devices and then take it out again when no longer needed. Mm-hmm. So those are vast amounts of data that needs to be shifted from one place to another. And of course, that requires a very efficient backhaul. Mm-hmm. So clearly, yes, it is absolutely necessary for the success of 5G.
Okay. Something you mentioned earlier on was to do with the kind of fixed wireless infrastructure. And this would be in the case of a private network. And there seems to be a little bit of sort of belief in that the industrial customers will start to use that for campus-wide or production site deployments. Do you see that happening, firstly, and do you see that there may be regional differences in the way that private networks are deployed?
Mm. Well, so far there's only a limited number of private 5G networks up and running in the world. But some of the more significant ones are in the Asia-Pacific region, or in China specifically. BMW, for example, has 3 plants today which are operating private 5G networks inside China. And you're talking about thousands of base stations that have been put up in there. And they will replicate that into other places of the world. First in Europe, of course, it's a European company and they do a lot of their manufacturing in Europe. But they will also move it to other parts. So Europe is very clearly moving towards private 5G LTE networks. 5G networks. And if you look at the equipment manufacturers, the major ones all have their own solutions for this. Ericsson has what they call the Industry Connect program, which is a specific overall solution for manufacturing plant automation using 5G. Nokia has a very similar thing, which builds on their private LTE, and they're taking the same concepts into the 5G environment. And Huawei in China obviously has already been working with BMW and others to do the same thing. So what we see is Asia Pacific driving this going forward, and a lot of manufacturing in the world is in the Asia Pacific, then Europe, and perhaps a little bit later on in the US as well, as manufacturing gets onshored back into the US.
Okay. Let's talk a minute about the application area. What type of application? I know this is probably a difficult question in many ways, but how are applications going to form? Are they going to sort of be specific to like an industrial or a medical application? Do you see any, at the moment, early in its deployment, that some applications will become, a sweet spot for 5G?
There's a couple of them that we think are very ripe for being 5G use cases. In our own advanced manufacturing labs that we have around the world, and specifically one that we have in Singapore, we're now putting 5G in place to demonstrate how it can enhance existing applications. Mm-hmm. And there are 2 areas where we do this. One is visual inspection, where we have several cases. Some use a robot to look at wafers inside a semiconductor plant, lift them up, inspect them for faults, and then sort them accordingly. Today, we're sending that information frame by frame back, and we're also sending some control issues or control actions to the robot itself. But we're not streaming it. It's actually sending little packets here and there because we have limitations in the current network. And with 5G, we can stream the data. Another example is that in Malaysia, the freeways are being monitored by an IBM solution at this point. What we do is we look at license plates and we use that for toll purposes. We can also identify the type of car, the make of the car, etc. That information is sent back into Singapore, into a control center, where we have a big dashboard app where we can look at this. We're now enhancing that with 5G so we can actually track the vehicles in real time, again by streaming data rather than sending it frame by frame. Another use case that we're very happy about also is acoustic analysis. In a lot of cases, visual inspection is not the best way of doing things, because you have to open the machine up, you have to open the car up, you have to open up whatever you want to look at. But with acoustics, you can actually have the possibility of isolating specific sounds, and they can be within the range that you as a human can hear, or they can be below or above that. But as long as the microphones can capture it, we can identify whether there is a problem or not. A great example of this is airline engines, aircraft engines. Yes. They have to be taken down and inspected after a certain amount of hours of use, right? Mm. But it's a very, very costly proposition to do that, to dismount a complete engine and put it back again. With acoustic analysis, you don't have to take it off the plane. You can actually listen to it and identify specifically what the problem is. In our Singapore labs today, what we do is we listen to chassis for computers, for the fans in the computers, to see whether those fans are operating at the right level and keep the right temperature. But in order to train the machine to do this, we use artificial intelligence. And that server is not located in Singapore, it's located in Dallas, Texas. So sending all the files back and forth require massive bandwidth, obviously. But with 5G, we can do that. But we can do even better. We can optimize it even further, so that we actually only send specific information initially, have the machine learning going on in Dallas, and then instructions being sent back. And then once the machine had been trained and it learned everything, then we can switch back to another level of networking, less bandwidth, less latency, etc., on a local level.
Yeah. And this sounds ideal for the kind of the preventive maintenance, the MRO regimes, which really brings it to life. And like you say, I mean, monitoring fan bearings or motors, this is an ideal use case for the industrial.
Ball bearings is a very good one.
Yeah. Yes. Michael, do you see many regional differences in the way that applications are going to be deployed? Do you see that some are going to develop faster than others?
Absolutely. If you look at the world today, 5G is only deployed in a few countries. You have South Korea, definitely leading the field at the moment. You have more than 90% coverage of the country. We have close to 100,000 base stations up and running, and all three operators have 5G networks in play. And there are phones from both LG and from Samsung available to consumers. So there's about 3 million consumers using 5G today in South Korea, which is far more than in any other country. The US would be the second largest one. But here in the US, the deployment is not for the mobile user like in Korea. It's a fixed wireless that we talked about earlier. In Korea, on the other hand, since we're talking about mobile users and the phones, what they use it for is exactly what they have been using it for previously, which is streaming video, usually downstream from a provider of content down to the end user, or for gaming. And in both of these cases, and some AR applications, which is new for the games. But that really makes use of the new 5G functionality from a consumer standpoint. In other countries, it doesn't seem to happen that way. Like I said, the US is fixed wireless. If you go to China, if you go to Japan, we're talking manufacturing solutions more than anything else. And the same thing goes for Europe. So yes, there are very distinct regional differences. And I think those will probably persist over time. I don't see much changing in that respect.
One application area seems to be for use in smart cities. And to a point you raise about streaming video, I see that there seems to be two schools of thought. One is that you stream the video and have the kind of the AI intelligence more, at the server end, or you provide that intelligence at the actual edge. How do you see 5G will influence those applications?
There's a very strong trend to move intelligence as far out in the network as possible. Edge computing is definitely what is the way forward. What we see is a hierarchy of networks stacked on top of each other, where latency determines how far you want to go. And for most control applications, whether you want to control a robot, you want to control any device in real time, you have to have it as close to the edge as possible, put the intelligence as close to the edge as possible. Now, if there is a matter of machine learning, for example, or a situation where you train something for a while and then move it down, that you can shift further up into another cloud, a little bit further back in. So in a typical city, you would have a lot of edge computing, a lot of sensors, and if they are in need of real time you would have the intelligence very close to them. If it's more about storage, if you store a vast amount of data and then you have some analytics going on in the background to see trends over time, or to build a digital twin that you can monitor, sure, you move that further back.
Interesting. When we look at our homes, we're very dependent upon a wired infrastructure in our homes to provide our kind of broadband service. Do you see that there's a chance that 5G will replace that last mile challenge by actually having internet provided through 5G rather than the traditional Wi-Fi router?
I think a lot of customers would like to see 5G coming into the home as well, because of the dedicated bandwidth that you have and the guaranteed functionality, etc. Because it's a deterministic way of providing the information. But the problem is that 5G is using licensed spectrum, which means that you as a user typically cannot walk into the Best Buy or the Dixons or whatever store that you buy your routers from and deploy it yourself. You would have to go through the operator, get the license, and have the equipment installed. With Wi-Fi, you can just go and get it and you put it in place yourself. And it uses unlicensed spectrum, so you don't really have to worry about any operator being involved. So I don't think you will see 5G all the way into the home that much. I think Wi-Fi still has a very big role to play there. And especially now, since you have new specifications of Wi-Fi, Wi-Fi 6 coming out, for example, with enhanced functionality compared to previously.
Yes. And presumably, your previous point is that a lot of 5G deployment will be done within the cities first rather than moving outside. Do you see any changes to that, or do you think that a consumer-led requirement of 5G will change that deployment schedule?
Well, the main reason why we see 5G being deployed in cities first is because of the frequencies being used, and you want to reuse the spectrum as many times as possible. So you have fairly high frequencies that you're using. They don't propagate very far. So if you want to go out into a rural district, you would probably want to use a lower part of the spectrum, which is why you're refarming some of the 2G frequencies to be used in 5G, so they can go out into rural areas. But that's going to happen over time. That's going to happen initially. And 5G is not designed for major rural deployment. It's designed for high density areas. And it's primarily a industrial use technology rather than a consumer one. Consumers will be using 5G because it's available. Operators will provide 5G because there is a demand for some of the functionality. But if consumers were the only users of 5G, you would see a 2-3% revenue increase per year for the operators. When you go industrial, you're talking about a 30-40% increase per year in revenues.
Yes.
And without that, if you don't go that industrial route, the operators will not have sufficient funds to deploy 5G in the first place. Yes. So it's very clear which way it's going.
Yeah. So we've talked quite a bit about industrial and commercial applications and for manufacturing. What about things like emergency services, fire, ambulance? Is there a need for 5G there?
Oh yes, definitely. In the US already, the first responder networks are being looked at as the first instance of 5G for public safety and public services. What you want to do is to have some of the 5G functionality enhance what is already being done. To give you an example, if there's a fire somewhere, we have a 2, 3, 4, 5 alarm fire, where you will have trucks coming in from all over the place. You want to be able to, first of all, make sure that you have a green wave to get the fire trucks to the place where they want to go. So you need to be able to control in real time based on how the traffic is flowing. So you need traffic monitoring, you need to identify the vehicles as they pass through. You need to make sure that they get a green light when they come to certain crossings, etc. Yes. And you want to redirect other traffic away from it. Then for the people on board the trucks, you want to make sure that they have all the information they need about what's going on at the destination where they're going. And that includes live video to show what is the fire looking like at the moment, how is it growing, is it expanding, is it contracting, what is going on. And second, you want also to get other data to them, for example, the blueprints of the actual building that they're going into, to make sure that, okay, this is the kind of building it is, these are the floors, here's where the fire equipment is being stored at the moment, etc. All that information you need to have to the truck, and it has to be done in real time. So that's a very typical example of what's going on.
And presumably, like with networks today, there will be an opportunity for emergency services to prioritize their data traffic above other traffic within the network.
Oh, absolutely. That's a matter of quality of service, what you want to put in there. But you can also use specific network slices for specific purposes. You can prioritize, say, bandwidth if video is a real demand going on here. You can prioritize latency if the real-time aspect is something that is important. And you can also prioritize or have multiple channels of information in parallel based on the network slices. And there are many things that you can use, not only video. We talked about acoustics previously.
Yes.
Acoustics is also used here. If you go to, say, Redwood City in the Bay Area in California, you have listening stations at lampposts in a lot of places around the city. And as soon as you hear gunfire, you identify exactly where is the location of that gunfire. But even more, now if you have a machine behind it that is actually trained to identify the sound, you can also tell which model of rifle or gun was being used. And if that specific one has been used before, you can also identify the owner. So these are some of the new things that you can do.
And I often wonder whether 5G is a situation that you get these high expectations of what it might be actually like. But when it comes to reality, will it be like that, or will it be a tortuous process to get to what you want?
You know, the classic response to this is that typically any new interesting technology is overhyped in the short term,
Yes.
but is actually underhyped for the longer term. And that's very true, I think, for 5G as well, because you won't see the implications of 5G until it's truly deployed out there. And it's not just, in my view, it shouldn't be called 5G, it should be called 1H or something else, because it's really a radical shift. 1, 2, 3, 4G were all consumer technologies which built on each other to enhance consumer communications, people to people. What you're talking about with 5G is no longer that. That's just an add-on. People will use 5G because it's there, but it's not being designed or built or deployed for them.
No.
And they will not finance a build-out.
Yeah.
So it's a completely different generation.
Yes, and in many ways, I mean, I don't think going from 2G, 3G, 4G was pretty seamless, and it's suddenly the only time that you would notice it would be on your phone screen. There may be a 4G come up. It was not disruptive, but is 5G going to be a little bit more disruptive from a consumer perspective, or not?
No, I don't think so. You will see a big step up in bandwidth, yes. But you can already stream today. I mean, I can get Netflix on my phone today, and in most places, it would run okay. I wouldn't have a problem with it. Adding 5G capability, yeah, okay, I can go to 4K video then. But on my little screen, that really doesn't matter. So it's irrelevant, right?
Yeah.
The number of devices, well, your typical consumer has 5, 6 IP connected devices, maybe up to 10 in a couple of years. And that's not enough to require a massive device connectivity. Companies might need that. Factories definitely need it. As a consumer, no, I don't think so. So it's not a consumer technology, and it's not disruptive for the consumer, but it's very disruptive for industries. That it is radically shifting the way we will do manufacturing. It will radically shift the way public services are provided or public safety is handled. So a big difference there.
And a lot more devices. If we look at the industrial Internet of Things, that the possibility of every device is 5G enabled.
Well, you're already talking about 3 to 4 billion devices within the next couple of years in IoT, and that because of all the sensors that are put out there. And the reason we're doing this is that the price is coming down for everything that is related to what 5G is using. The price of, well, to give an example, what you do is, when you look at networking, so you have 3 components. You have the computing part, you have the networking part itself, and you have the content, right? Those are things in here. Now, to process a mega, a megahertz of information, right? Back in the 70s, you were talking about $100,000 to do that. Mm-hmm. Today, the cost is below a cent, far below a cent, right? If you're talking about transmitting a terabit of data from point A to point B, you were talking millions of dollars back in the 70s, now a fraction of a cent again. Mm-hmm. So you're rapidly approaching zero for all the major components involved in here. So where is the value then? There's no value left in all this. The only value that is left is in what is actually being sent through.
Yes.
And that's why it's going to be so disruptive. It's not the technologies anymore, it is what it's being used for.
Yeah.
So the value is shifting from whatever hardware you see to whatever service is being provided.
Yes.
And that's a major, major shift. You don't charge for a connected white goods manufacturer, like a connected fridge or a washing machine, right? You can't add much to the price of that. But what you can do is you can provide it as a service. In other words, the machine is being sold on a recurring basis.
Right.
Every 5 years it's being replaced automatically,
Yes.
and all the time it reports back whatever is going on with it, how many cycles it has run. You can even charge per cycle if you want, based on the networking
Yes.
connectivity, instead of selling a piece of hardware.
So a
Very disruptive.
whole new range of business models can come for, typically where capital assets have been sold, quite capital intensive assets have been sold as a one-off.
Yeah.
Now the opportunity to supply on a service provision basis is something that the IoT
Exactly.
will provide.
In very short terms, industry after industry will shift from a thinking about CapEx to thinking about OpEx. That's really what is happening very quickly.
Mikael, thank you very much.
Well, thank you. Thank you for having me.